Okay, so here is Unit 5, Day 2. We're going to do that second version of solving systems. We told you there's basically three ways. So today is going to be substitution. So I can solve the system using substitution. Some of you might like this better than graphing, some of you might not. It's really kind of a preference. So which method have we already learned? We already learned graphing. And some of the drawbacks of graphing, I don't know, maybe you ran into these on the homework. Sometimes the intersection of the lines, or intersection of the lines not on the graph. So for instance, here's your viewing window, here's the y-axis, x-axis, here's the first equation, there's the second equation. And you say, well, they're not parallel, so I can't say no solution, but I can't really find the solution. So it's really hard to tell because it's somewhere over here off the graph is where they actually intersect. So that kind of stunk sometimes. And then another one is the intersection of lines is not at nice, neat points. Okay, maybe you had that grid line, something like this, and the line's met like this. Well, it's not 2, it's not 3. It's really hard to tell because it's kind of at a weird spot. So those weren't very easy to find. And sometimes you had to put the lines in the slope-intercept position. Okay, so when we did we'd give to you in standard form sometimes, and it kind of stunk because you'd have to put it into slope-intercept form to graph it, and then it just kind of made it a pain in the butt. So the next method, substitution, takes care of those problems. So these three will never happen with substitution. Okay, it doesn't mean it's like a cure-all going to be so much easier and you're going to have a blast and boy, I'm sure glad we learned this. But some situations it's way easier. So the goal is to solve a system by changing one variable into an equal expression containing the other variable. Basically, I just want to get a variable by itself. So in other words, instead of two variables, we only have one. So I want to eventually eliminate. So how we do that? So the important first step is get one variable by itself in on at least one of the equations. So one of those equations, you got to have a variable by itself. Okay, and sometimes it happens for you. Like this first example, which one of these variables is already by itself in one of the equations? Well, this guy right here, y is already by itself. Perfect. That's exactly what we want to do. Okay, so what I'm going to do now, and think of this, think y and x minus 7, they're the same thing. They have the exact same value. It says they're equal. So think of this like, maybe not all sports fans, but think of this as a game, football game, baseball game, soccer, hockey, whatever. I want to get myself in trouble with soccer and hockey because I don't know the position so well, but I'm thinking, football most people know. So in football, you have a quarterback. So you say this is the game right here. This is the game. You have a quarterback right here, and you have, I don't know, say the wide receiver right here. Well, if I take the quarterback out of the game, it'd be really silly not to put another quarterback that's equal to it. I understand there's starting quarterback and there's the backup quarterback, and one's always better than the other. But if I took a quarterback out, I need to put a quarterback in. Well, up here, this says that something equal to the quarterback is x minus 7. They're interchangeable. So here's my game. I have this vacancy here. I took the quarterback out. Okay, so now that position needs filled. I'm going to put another quarterback in its place. So I'm going to put x minus 7 in its place. Okay, so I took the y out, I put something that y equals back in its place. So now I've got 2x plus x minus 7 equals 8. Notice this equation has one variable. If it has one variable, you can solve it. Okay, up here, this guy had two variables, this equation had two variables. So there are infinitely many numbers I can come up with that would make that true. Okay, I could have done 4 plus, or 4 here and 2 here, and that would work. Or I could do a 1 here and a 6 there. There's a lot of different, but here there's only one number I can plug in for x and make that true. Okay, so I want to simplify this. So 2x plus x would be 3x minus 7 equals 8. Okay, and then if I bring the 7 over, so now my goal is just simply solve for x. We did a ton of this earlier in the year. 7 over, so I got 3x equals 15. So now x, if I divide by 3, equals 5. Okay, some people think they're done there. Remember from last lesson, the solution is an ordered pair. So yes, x equals 5, but I need to find y, because I need to find an ordered pair. So what is y when x is 5? Well, with substitution, go back to that equation where you had a variable by itself. Here, x and 5, those are, you can think of that, that's your new quarterback. Okay, so your quarterback is x, take him out of the game. So x minus 7 was my offense. I took the quarterback out, and I need to put the backup quarterback in his place. Something equivalent to it is 5. So I took x out and I put 5 in, so y is going to equal 5 minus 7, y equals -2. Okay? If this was a test or a quiz and you want to make sure, plug in 5 and -2 into both these equations and it'll make them both true. Okay? Again, some of you might have thought, well, I'd rather just graph. Graph would have been easier on that. Well, this would have been easy to graph. I don't know about that. And then it also depends on if it would fall on the graph or not. So we'll get a little faster with these, hopefully. Here I've got x equals this and x equals that. Because the system, x always equals x. X is the same thing. So if these both equal this, that means this expression and that expression must equal this. They both equal x, they must equal each other. So -2y plus 1 equals y minus 5. Notice one variable here. I can solve that. So let's get the y's together. I think it'd be easier to add 2y to both sides. So I got 1 equals 3y minus 5. Bring the 5 to the other side, so I'm going to add 5. I got 3y equals 6. Divide by 3. So in my ordered pair, in my answer here, remember this is not my answer, this is half the answer. Y is 2. So I put a 2 in the y place. Now back to an equation where, because I'm trying to find x, look at an equation that has x by itself. Well, you have options. This one looks a lot easier to me. I'd rather plug into that one. So x equals y minus 5, y equals 2, so 2 minus 5. So that'd be -3. Okay. This guy down here, look for a variable that's by itself. Well, none of them are by themselves. This x is not by itself. This is being multiplied by 4, being multiplied by 3, being multiplied by -2. So none of them are by themselves. But which variable would be really easy to get by itself? I do one move and I can get it by itself. And that'd be this guy right here. That x, if I could subtract 4 to the other side, so I'm going to do this, x would equal 11 minus 4y. So if I subtract 4y over, it'd be 11 minus 4y. Now I got a variable by itself. So in this equation, I'm going to take x out. So I rewrote the whole equation, but I left a space for x. Put in something that equals x. 11 minus 4y. When you substitute an entire binomial like this, like over here it was always just 1. Like this was y, y was by itself, x was by itself. Here I got to multiply by 3 though, so think that's a set of parentheses. Okay, so I'm going to distribute. Again, y's, there's just y's, no x's in this equation, so a lot easier. So I'm going to distribute, so it'd be 33 minus 12y minus 2y equals 19. Combine those, 33 minus 14y equals 19. I'm going to subtract 33 over. So negative 14y equals negative 14. So that means y equals 1. Because I divide negative 14 by negative 14. So y is 1. Let's go back and find out what x is. It's always easier to use your equation that already has a variable by itself. I'm trying to find my x. Right here's an equation that has x by itself, so use that. So x equals 11 minus 4 times 1. Okay, take y out, put 1 in its place. 11 minus 4 is 7. Okay, so 7 comma 1. This guy here, I'll go a little bit faster. Which variable, first, is there one by itself? The answer is no. There's none that's already by themselves. Can you easily get one by itself? Yes. Okay, now there's 2 here. Which one's easiest to get by itself is what we're going to ask. So that's definitely this guy here. Okay, now that y is almost by itself, but it's a negative. You could do that if you want. I'm going to do this one because this is a positive. So I'm going to bring the 2y over. So it would be x equals 16 minus 2y. So in the first equation, up here, I've got 5. I'm going to leave a space. Minus y equals 47. So I took x out and left a big space in there for x. Now, write down what x equals. X equals 16 minus 2y. Okay, so do some distributing here. Distribute. See, 80 minus 10y would equal, and then minus y equals 47. Combine your y's together. So it'd be minus 11y equals 47. Subtract 80, I got negative 11y. That'd be negative 33, so divided by negative 11. So y in this case is 3. Once you have a variable, look for an equation that has the one you're looking for. I'm looking for x by itself, and that's this guy. It always works like that. It's going to be that first thing, that first variable you got by itself. Use that equation. So I'm going to say x equals 16 minus 2 times 3. 16 minus 6 is 10. Okay, so we got 10 comma 3 is my answer. Okay, let's see here. Special cases. Okay, special cases here. So this backside, we're going to do these two also. If you remember last unit when we were graphing, sometimes the graphs didn't intersect. They were parallel to each other. Sometimes they were right on top of each other. So we had no solution, infinitely many solutions. Well, when you're doing substitution, it's not always so clear. So we have to be able to interpret the answer. What happens? What will happen that tells us, oh, that's no solution? Well, that's infinitely many. So here, y is by itself, perfect, because that's what we need. We need a variable by itself. So I'm going to go to the other equation. I got 6x plus, I'm going to leave a big gap for y. What y equals? Negative 6x plus 1. Okay, so when I go to simplify, I got 6x plus negative 6x, so that's no x's, plus 1, so the left side equals 1. How on earth, I mean, first off, I get stuck because there's nothing to solve for anymore. There's no variables. Variables disappeared. Okay? But how on earth can 1 equal 10? Like, there's no universe where 1 equals 10. So that is not true. This is not true. Not a true statement. Variables disappeared, but that's not true. If it's a not true statement, it's no solution. So think the ends, not true, no solution. Not true, no solution. If it's no solution, what would happen if I graph these? So if there's no solution, when I graph them, these lines would be parallel. Okay, let's go to this guy over here. Probably guess what's going to happen. If this one's no solution, this one's going to be infinitely many solutions, but let's do it anyway. Kind of look at what happens. So I got a variable by itself. Perfect. So I'm going to go to this one up here. I got 2. I'm going to leave a big gap for x. I'm going to plug in what x equals, so negative 2y plus 4. Distribute, so this would be a negative 4y plus 4 plus 4y. Whoops. I made a mistake there. The lights went off too. But 2 times 4 is 8. Okay. And then negative 4y plus 4y is gone, so that means I'm stuck with 8 equals 8. The variables disappear, so there's nothing to solve anymore, so that's a red flag. But the nice thing is this is true. Is true, infinitely many solutions. Look at the i's. Is true, infinitely many. Not true, no solution. So I or n. Now, if it's infinitely many solutions, these lines, if I graph them, they would be the same line. Okay? So in these two examples, these two examples are special. They are special cases. Okay, the mom told them they were special. In cases, since in both examples, the variables disappeared. Or they canceled out. They wipe each other out. The difference is, if there's no solution, the variables cancel and the remaining numbers are not equal. Okay, so no solution, not equal. Infinitely many, the variables cancel and the remaining numbers are, I'll say, in fact, I'll change this to is equal. Doesn't make sense, numbers, but is true. Maybe we'll say that. So is true. The remaining equation, I don't like that. I wish I had changed that. Equation. So the variables cancel and the remaining equation is true, infinitely many. Not true, no solutions. Hopefully that helps you remember. So hope you enjoyed that.